We're going to continue our discussion of functions by looking at function notation. Some of you guys may have seen this before, but the idea is that there's some special notation that we'll start to use a lot that help us work with several different functions at one time and clarify some certain situations. At first, it may seem a little confusing, but we'll get through that as quick as we can. First of all, when you're dealing with functions, y equals f of x. And it doesn't have to be f of x. It could be g of x or h of x or anything of x. But we're going to usually use f of x because f is function. So with functions, in the old way we had points that were x and y. Points with functions are called x and f of x, where f of x just replaces y. In equations, what this looks like is instead of y equals 2x, we'll have f of x equals 2x. So it seems pretty simple. Some of you may be wondering why, but we'll get to that a little bit later. Where x is the input or the domain, and f of x is the output or the range. Okay, and so let's look at an example. So given that f of x equals 2x, find f of 3. And that's where we get into this. So everywhere that there's an x in f of x, you're going to put a 3. Let me get a pen out here. We'll use red. Okay, so you can see here there's my x right there. So everywhere that I had an x, like there, then I'm going to put in a 3. So I say 3, f of 3 equals 2 times, and then I put that 3 in there, and I usually put in parentheses because that really helps out. And we can see that 2 times 3 equals 6. Pretty difficult stuff here. Next, let's look at another one. So we have g of x equals 3x plus 5x, 3x squared plus 5x plus 2. Let's find g of 1. So what I'm going to do is I'm going to write down g of negative 1, and that's how you say it. It's the funny way. G of negative 1. So everywhere there's an x up there, I'm going to put in a negative 1. The way I like to think about it is first I put in parentheses everywhere that I need for every x. Okay. And then I'm going to put this negative 1 in everywhere. Got the squared, okay? Everywhere that there are parentheses, okay? Now we can start evaluating. I'm just going to rewrite this g of negative 1 right there, okay? And the equal sign. Now, so then I have 3 times negative 1 squared is positive 1, so I'll just rewrite that there. 3 times 1 plus 5 times negative 1 is negative 5, and then plus 2. That just comes down. 3 times 1 is 1, plus 5 is negative 2, plus 2 is 0. So then we would say that g, for the function g as described above, g of negative 1 equals 0. And we could also rewrite that as the point negative 1, comma, 0. Okay, so that's how, one of the nice things about function notation is that it tells us where to put things in to our equations. Now, another thing that you might run into is, let's say that we had our function earlier that was f of x. Let's use a different color to erase that, get rid of that. We'll go back to black. Let's say that we had f of x, and we'll remember that that one was defined as f of x equals 2x. Now, one thing we might have is a situation where we want to find out where. So last time we looked at inputting for x. Now, sometimes we'll see that f of x, and we'll be given what it equals. Let's find out when f of x equals 10, let's say. Okay. Now, last time, the g of was on the inside there, was was on the inside right there, inside the parentheses. This one is where f of x equals 10. So we're going to replace f of x in this equation with 10. So I'm just going to take this and I'm going to replace f of x with 10, and I'm going to say equals 2x. Oh, now we've got a little problem to solve. No big deal, right? We just divide both sides by 2, and we will see that 5 equals x. And we could say that the point that is the solution is the point 5, 10. All right. Let's move on to the next page. Sometimes we'll see functions as, zoom out a little bit here. Sometimes we'll just see graphs of functions. So we have this function h of x. Now, first of all, is it a function? Well, yeah, if you drew a vertical line anywhere through this graph, you would in fact see that it never crosses the same place twice. Now, if it's not clear, like in this area, it's not perfectly clear, we can assume that it only crosses through once and it gets really close to vertical but doesn't actually go vertical, unless it obviously doesn't. Now, so now let's answer a few questions with this. Okay, so I'm going to go in here and I'll drag down my little screen. Let's find where let's find h of 40. So we have inputted 40 into our equation. So we're going to go look at 40 here, and we're going to go and look and see what the corresponding value of the function is when x equals 40. And you can see that it is about 110 right there. Okay, so we could say that point is 40 and 110. And so we would say, well, h of 40 is 110. Okay, let's move on down. Now let's look. Now here's a couple of the other type of questions. So you can see where h of x equals 160. Well, if we drew a line where h of x equals 160 right there, then you can sort of see that it looks like that at about, what's that, about 58, we'll say? About right here, that's where h of x equals 160. So we'll say that, we'll estimate x to be about 58. It's a nice 58 there. I guess I'll try and write that a little bit better. Probably make it worse, but here we go. 58. All right. Now, as we move on down, let's see when, let's look at our function and see when it's going to equal, when our function, our h of x, is equal to 130. So then I'll just draw my line across at 130, and you can see it equals it in a few places. And we can estimate those places where it equals 130. Looks like it about when x equals 10. And then it also looks like it equals it at about, what would you call that, 26-ish. And finally, you can see that it equals it at about 54. All right. So there's our discussion of function notation. We'll talk about it a little bit more, but the big ideas that I want you to remember are that, that f of x, although it doesn't always have to be f, is the same thing as y, okay? And when I say, for example, f of 2, we replace the x in the equation with 2 everywhere that there is one. And then if I say f of x equals 2, then that means that we're going to replace it outside the equation, or we're going to replace f of x with 2. Okay? And we will talk about this more in class tomorrow. Thank you very much.